Okay, so it's time to get our robot actually moving, all right? And to do that, we have a couple of options. We can actually hook up the servos and use the servo library, which is included in Arduino. And that works okay. It doesn't have a real good sense of resolution since it's based on time. Or we can use the library that was written by Chrysodom, which actually is based on the number of steps that the robot actually takes and the number of pulses to the servo. And that's one we're actually going to use for this class. So to do that, we should probably first off hook up the servos in the same way for everybody. That way we can share the code and share the module that we're going to be using to make this guy go. So to do that, I'm going to get these wires kind of untucked here. Hopefully you have your robot fully assembled. And what I want you to do is I want you to find the servo on the left. Now keep in mind, the front of the robot is here. Okay, the cutouts are on the back of the robot as well as the tail ball. So I'm going to assume that my robot is going in this direction when it's going forward. All right, so it's going to go this way. And with that orientation, that's going to make this my left servo and this my right servo. All right, so what I'm going to do first is I'm going to find the wire that's connected to my right servo. So I've got a hold of it here. I'm going to feed it up. And what I want to do with it is I kind of want to, you don't have to do this, but I'm going to kind of do a little twisting on the wires just to, because I want to tuck it out of the way. I'm going to be able to put it underneath my standoffs. So that way the wire doesn't really get in my way as I add more sensors and electronics and batteries and stuff. Okay, so if we're going to work together on this and keep it uniform, we're going to plug this guy into the same on all of our robots. So that is going to be, in this case, I'm going to have my right servo on pin 12, which means it's going to be in the very last set right here. Okay, so that's my right servo, very last set. White goes on yellow, red on red, black on black. Really important. Don't flip this around. That can actually damage the board or the servo. And I'm going to do the same basic thing then with my other one. There, so this is my left servo. And I'm going to kind of twist it up like this. And I'm going to plug it in the same orientation. In this case, I'm not going to plug it into, this one's 12, so the one right next to it is 11. So I'm going to plug it into pin 11. White on yellow, red on red, black on black. And then I'm going to go ahead and tuck these wires in underneath here like so. Okay. Now, what we want to do next is we want to download the module that we're going to use to drive these servos. Now, as a George School student, that's going to be accessible from Canvas. And I'll find a place to put it for anybody else so they can have it. It's also in chapter 18 of Chris Odom's book. You can just copy and paste it from there. But we'll find a place to post it so you can copy it and use it independently. So, that being said, I'm going to go to Canvas, which is our school's learning support module. And this would be a typical page, home page on a class of mine. And we're going to go to Files. And then Files, we're going to go to Modules for GS or George School Students. And the one we want is the Servo Motion Module. Okay? And I want to do is I don't want to open it. It's real important. Don't open it. Don't create a folder. It might ask you if it can create a folder, yada yada. Now, I don't want to do any of that. I just want to download it. Okay? So just download the Servo Motion Module. And hopefully you're just going to put it in downloads either on a Mac or PC because we're going to need to find it here in a second. So it's downloaded. It's ready to go. So I'm going to get rid of this. And now I'm going to go ahead and open up a sketch. And it's a brand new sketch. Okay? And what I'm going to do now is, I should pull this down so you can see the menu. I need to then link that Servo Motion module to my new sketch. That is done by going like this. You go to Sketch, you go to Add File, and then you simply find the file location where it was at. So I'm going to go to Canvas, I'm going to go to Downloads, I'm going to find the Servo Motion module, which I just downloaded, and I'm going to say open. And there you go. So notice it's a new tab up here. Okay, we'll talk about tabular programming or module programming in the not too distant future, but right now it's come up as a new tab. And pretty clearly you can see labeled here this information that says copy everything below and everything above. Okay, so what we want to do is we want to capture this information right here and we want to paste it into our main sketch. So I'm going to copy this. I'm going to go to my main sketch. Notice it does include a new setup. So that means I want to get rid of my existing setup because I can only have one setup and paste it in. Alright? And now I have this hunk of code. And this is why it was important for us to work together. My left servo is on pin 11. My right servo is on pin 12. And you can see that in the setup, those pins are going to be set to output so they can drive it. And I also have this LED activated, the onboard LED, which is this LED right here. And it's going to call up a function called blink LED 5, and we can see that right here. Okay, so this is where the functions are, actually on this other tab, and it's going to cause it to blink the LED 5 times. Alright, so let's go back over to our sketch. I'm going to save as right now. Actually, I'm just going to save it as default because I'm going to do this a few times. And now we need to test it, see if it works. Okay? So let's go ahead and give it a whirl. There's actually a little program or a test program. There's two of them actually here. There's a motion fast test and a motion slow test. I'll take the fast test. I'm going to copy it. And I'm going to put it right here in my loop since it's just a test. Now I do want to make sure that it doesn't loop and loop and loop, or my robot would just keep going and going and going. Okay? So I'm going to create some kind of a for loop or a while true or some sort of infinite loop that's going to tie it up so that it only runs one time. Alright, that being said, I think we're ready to go. You can see my board is already plugged in. The system is on, which means this chip is powered. And of course this side is powered. But this side is off, right? So this switch is off. This green light is off, which means there's no power going to these cables right here. Also note, I do not have any batteries on this, so I'm running it entirely off my USB power, okay, which is fine on my PC. But here in a moment I'll talk about how you can bypass that if necessary if you're running on a lower powered, lower USB Mac or a Surface Pro or some other long battery life device. So let's give it a whirl. All right, I'm going to verify it, and I'm going to upload. Now what should happen is the first thing it's going to do is it's going to call this and it starts to blink. While it's blinking, I can turn on this switch, and lo and behold, you can see that my robot is going through a series of movements with the wheels switching directions. And of course it now has the infinite loop, so it's just going to be idle now. And I can turn this back off again. It's important in many cases to make sure this switch is off and this light is off when uploading. If the motors are powered or engaged, oftentimes that draws simply too much power to be able to effectively program or upload to the chip. So we want to take the load off by switching that off. And that also explains why the delay is there. The delay gives you an opportunity to go ahead and flip on the switch and after it's uploaded while you still set down the robot. And it's worth noting that if I unplug this, of course my power goes down. I'm going to temporarily put a battery pack on here, like so. And I can turn on the processor. The light will begin to flash. I can turn this on, and you can see now that the code is fully installed on the machine, and it'll just run completely autonomously, untethered from the computer. Now the couple of notes about lower power devices. If you're using a Mac, or some other device that just doesn't have a lot of power, there's a jumper right here. Now this jumper effectively bypasses this switch. So you'll notice I've got batteries on right now. It's plugged in. And if I turn, right now the power is off, okay? But if I put this jumper in place, the power is coming on. And in fact, you can see the processor's already begun to process and it's running the code. And if this was on, the motors would begin to run, okay? Even though the power switch is off. So what that means is that if I plug this in, okay, I am now powering the system from two sources. I'm powering it from my USB cable and I'm powering it from my batteries. So the upside of it is that I can upload and download code without having to worry about drawing too much power from my USB, because the bulk of the power is going to be coming from the supplied pack. The downside of it is if I do something really silly, short it out, spin the wheels, backfeed electricity into the system, that can make its way up the cable and into your computer. Nowadays, most every computer I've seen for the last several years has some sort of circuit protection, and that doesn't lead to anything except the temporary shutdown of the port. But it's still worthy of note and should be, care should be taken. Okay? So that being said, I think we've gotten the initial test. We have this servo motion module installed and utilized, and we've tested the system. So I'm going to end this video, and then on the next video we'll explain what actually happened, and then we'll take it a step further and move the module around and show how you can use it with other programs. So I will see you all again soon.